The Occupational Safety and Health Administration, or OSHA, requirement for arc flash is located in 29 CFR 1910.269 ONA. This regulation states that the employer must determine, estimate, or measure the incident energy to establish the appropriate level of personal protective equipment, or PPE, for the specific task being performed. This means that employers are legally obligated to assess the potential arc flash hazard associated with electrical work and to provide employees with the necessary protection. To answer the question of whether training is needed to access electrical panels for troubleshooting purposes, the answer is yes. According to OSHA's 29 CFR 1910.333, only qualified electrical workers are permitted to work on or near exposed electrical conductors or circuit parts that have not been de-energized. The term qualified electrical worker refers to an employee who possesses the following qualifications. Firstly, knowledge and skills related to the construction and operation of electrical equipment and installations. This encompasses a comprehensive understanding of electrical systems, components, and their functioning. Secondly, training in the safety-related work practices applicable to the specific workplace. This training should cover the procedures and precautions necessary to work safely with electrical equipment in a particular environment. Thirdly, demonstrated safe work practices. This means the employee must consistently exhibit safe behaviors and adherence to established safety protocols while performing electrical work. In addition to OSHA's requirements, the National Fire Protection Association, or NFPA, has published NFPA 70E, Standard for Electrical Safety in the Workplace. This standard provides detailed guidance on arc flash hazards and the related training requirements. NFPA 70E serves as a comprehensive resource for employers and employees seeking to understand and mitigate arc flash risks. NFPA 70E recommends that all workers who may be exposed to arc flash hazards receive training that is tailored to their specific responsibilities and risk level. This training should encompass several key areas. Firstly, understanding arc flash hazards. This includes learning about the causes, characteristics, and potential consequences of arc flash events. Secondly, assessing arc flash risks. This involves evaluating the likelihood and severity of arc flash hazards in various work situations. Thirdly, selecting and using appropriate personal protective equipment, or PPE. This covers the proper selection, use, and maintenance of protective clothing and equipment designed to protect against arc flash injuries. Fourthly, safe work practices to prevent arc flash incidents. This includes implementing procedures and techniques to minimize the risk of arc flash events during electrical work. A deeper dive into understanding arc flash hazards is necessary. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. The fault can be caused by several things, including accidental contact with a live conductor, insulation failure, or equipment malfunction. When an arc flash occurs, it releases a tremendous amount of energy in the form of heat, light, and pressure. This energy can cause serious burns, blindness, hearing loss, and even death. The temperature of an arc flash can reach as high as 35,000 degrees Fahrenheit, which is 4 times hotter than the surface of the sun. The pressure wave from an arc flash can also be strong enough to knock people off their feet and cause structural damage. Assessing arc flash risks is a critical step in protecting workers from these hazards. A risk assessment involves identifying potential arc flash hazards, evaluating the likelihood and severity of an arc flash event, and determining the appropriate safety measures to take. There are several factors that can affect the risk of an arc flash, including the voltage and current of the electrical system, the distance from the worker to the potential arc flash source, and the type of equipment being used. Employers should conduct regular arc flash risk assessments to ensure that workers are adequately protected. Selecting and using appropriate personal protective equipment, or PPE, is another essential element of arc flash safety. PPE is designed to protect workers from the heat, light, and pressure of an arc flash. The type of PPE required will depend on the severity of the potential arc flash hazard. Some common types of PPE used for arc flash protection include arc-rated clothing, face shields, safety glasses, hearing protection, and gloves. Arc-rated clothing is made from materials that are designed to resist the heat of an arc flash. The clothing is rated in terms of its arc thermal performance value, or APV, which is a measure of the amount of heat energy the clothing can withstand before causing a second-degree burn. Face shields and safety glasses are used to protect the face and eyes from the intense light and flying debris of an arc flash. Hearing protection is used to protect the ears from the loud noise of an arc flash. Gloves are used to protect the hands from electrical shock and burns. Safe work practices are procedures and techniques that workers can use to minimize the risk of an arc flash event. Some common safe work practices include energizing electrical equipment before working on it, using insulated tools, maintaining a safe distance from energized parts, and wearing appropriate PPE. The energizing electrical equipment before working on it is the most effective way to prevent an arc flash. This involves turning off the power to the equipment and verifying that it is de-energized using a voltage tester. Insulated tools are designed to prevent electrical shock. These tools are made from non-conductive materials and are rated for the voltage of the electrical system. Maintaining a safe distance from energized parts is another important safe work practice. The distance required will depend on the voltage of the electrical system. Workers should always stay outside of the arc flash boundary, which is the distance at which a person could receive a second-degree burn from an arc flash. In addition to the above, there are other important aspects of arc flash safety to consider. Firstly, developing and implementing a written arc flash safety program. This program should outline the procedures and policies that will be followed to protect workers from arc flash hazards. Secondly, providing regular arc flash safety training to all workers who may be exposed to these hazards. This training should cover the topics discussed above, as well as any other relevant safety information. Thirdly, conducting regular inspections of electrical equipment to identify and correct potential arc flash hazards. This can help to prevent arc flash events from occurring in the first place. Fourthly, using arc flash hazard labels to warn workers of potential arc flash hazards. These labels should be placed on electrical equipment that may pose an arc flash hazard. Fifthly, following all applicable safety standards and regulations. This includes OSHA regulations and NFPA 70. By following these safety measures, employers can help to protect their workers from the serious hazards of arc flash. Remember that electrical safety is everyone's responsibility. Always be aware of your surroundings and take the necessary precautions to protect yourself and others from electrical hazards. Now let's delve deeper into the specific requirements of NFPA 70. NFPA 70 is a consensus standard developed by the National Fire Protection Association that provides guidance on electrical safety in the workplace. It is widely recognized as the industry standard for arc flash safety. The standard covers a wide range of topics, including arc flash hazard assessment, personal protective equipment, or PPE, safe work practices, and training requirements. One of the key requirements of NFPA 70 is that employers must conduct an arc flash hazard assessment to identify potential arc flash hazards in the workplace. The assessment should include an analysis of the electrical system, the potential arc flash incident energy levels, and the appropriate personal protective equipment, or PPE, required for each task. NFPA 70E also specifies the requirements for personal protective equipment, or PPE, used to protect workers from arc flash hazards. The standard requires that PPE be rated for the potential arc flash incident energy level and that it be properly maintained and used. The standard also includes detailed guidance on safe work practices for electrical work. These practices are designed to minimize the risk of arc flash events and to protect workers in the event of an arc flash. NFPA 70E also specifies the training requirements for workers who may be exposed to arc flash hazards. The standard requires that workers receive training on arc flash hazards, personal protective equipment, or PPE, and safe work practices. In addition to the above, NFPA 70E also includes information on electrical safety program development, electrical safety audits, and electrical safety equipment. The standard is a comprehensive resource for employers and employees seeking to improve electrical safety in the workplace. It is important to note that NFPA 70E is a consensus standard, which means that it is developed through a process that involves input from a wide range of stakeholders, including employers, employees, and government agencies. This ensures that the standard reflects the best practices for electrical safety. While NFPA 70E is not a law, it is often adopted by OSHA as a recognized industry practice. This means that employers who follow NFPA 70E are more likely to be in compliance with OSHA regulations. In addition to NFPA 70E, there are other standards and regulations that address electrical safety in the workplace. These include the National Electrical Code, or NEC, and various state and local electrical codes. It is important for employers to be familiar with all applicable electrical safety standards and regulations. To ensure compliance with OSHA regulations and NFPA 70E, employers should take the following steps. Firstly, conduct an arc flash hazard assessment to identify potential arc flash hazards in the workplace. Secondly, develop and implement a written arc flash safety program that outlines the procedures and policies that will be followed to protect workers from arc flash hazards. Thirdly, provide regular arc flash safety training to all workers who may be exposed to these hazards. Fourthly, ensure that workers have access to and use appropriate personal protective equipment, or PPE. Fifthly, implement safe work practices to minimize the risk of arc flash events. Sixthly, conduct regular inspections of electrical equipment to identify and correct potential arc flash hazards. Seventhly, follow all applicable electrical safety standards and regulations. By taking these steps, employers can create a safer workplace for their employees and reduce the risk of arc flash injuries. Remember, electrical safety is an ongoing process. It requires constant vigilance and a commitment to following safe work practices. By working together, employers and employees can create a culture of safety that protects everyone from the hazards of electricity. Let's also briefly touch upon the National Electrical Code, or NEC, and its relevance to arc flash safety. The NEC is a widely adopted code that provides comprehensive requirements for electrical installations. While the NEC does not directly address arc flash safety, it contains many provisions that can help to reduce the risk of arc flash events. For example, the NEC requires that electrical equipment be properly grounded, which can help to prevent electrical faults that can lead to arc flash. The NEC also requires that overcurrent protection devices, such as circuit breakers and fuses, be properly sized and installed to protect electrical equipment from damage due to overloads and short circuits. In addition, the NEC includes requirements for the installation of arc flash hazard warning labels on electrical equipment. These labels provide workers with information about the potential arc flash hazards associated with the equipment. While the NEC is not specifically an arc flash safety standard, it is an important resource for electrical safety professionals. By following the requirements of the NEC, employers can help to reduce the risk of arc flash events and create a safer workplace for their employees. Furthermore, understanding the concept of incident energy is crucial in arc flash safety. Incident energy is the amount of thermal energy that a worker could be exposed to during an arc flash event. It is typically measured in calories per square centimeter, or cal per centimeter squared. The incident energy level is a key factor in determining the appropriate personal protective equipment, or PPE, required for a particular task. The higher the incident energy level, the greater the level of protection required. Employers are responsible for determining the incident energy levels for all potential arc flash hazards in the workplace. This can be done through calculations, software programs, or consulting with a qualified electrical engineer. Once the incident energy levels have been determined, employers must select personal protective equipment, or PPE, that is rated for the appropriate incident energy level. The PPE should be marked with its arc thermal performance value, or ATP, which is a measure of the amount of heat energy the PPE can withstand before causing a second-degree burn. It is important to note that PPE is only one part of an arc flash safety program. Employers must also implement safe work practices, provide training to workers, and conduct regular inspections of electrical equipment. By combining these measures, employers can create a comprehensive arc flash safety program that protects workers from the serious hazards of arc flash. In summary, OSHA mandates employers to assess arc flash hazards and provide adequate PPE. Only qualified electrical workers with knowledge, skills, training, and demonstrated safe practices can work on or near exposed energized conductors. NFPA 70 provides detailed guidance on arc flash safety, emphasizing training based on responsibilities and risk levels, covering hazard understanding, risk assessment, PPE selection, and safe work practices. The NEC contributes to arc flash safety through grounding and nerve current protection requirements. Determining incident energy is crucial for selecting appropriate PPE. A comprehensive arc flash safety program includes hazard assessment, PPE training, safe practices, and equipment inspections. Remember that continuous vigilance and adherence to safety protocols are essential for preventing electrical accidents and ensuring a safe working environment.